Good morning, girls. Last class we done law of combination, chemical combinations. Okay. Today is some new terms we have to know, that is atomic mass, molecular mass, etc. What is atomic mass? We know the atom is very small and to calculate the atomic mass is very difficult. So in olden times, which one, oxygen and hydrogen was considered as the standard, okay, for calculating the atomic mass. Standard means that is what we are calculating, we are taking that as the model and we are calculating the comparing the standard atomic mass of the standard and calculating others atomic mass. Okay, but later it is changed to carbon 12 isotope. All of you know carbon is having atomic number 6, but it is having isotopes. 3 isotopes are there. What are the 3 isotopes of carbon? Carbon 612, carbon 613, carbon 614. So isotopes means next chapter it is coming in detail, but just I will tell you, isotope means the atoms of the same element having same atomic number. Here atomic number is 6 but the mass number is different, that is known as isotopes. Okay, so after sometimes we all considered carbon 12 as the isotope. Carbon 12 isotope is taken as the standard to calculate the atomic mass. Okay, so atomic mass means it is the, how we can define atomic mass. Atomic mass means it is the ratio of atom of an element to the 1/12th mass of carbon 12 isotope. So what is atomic mass? How we can define? It is a ratio of atomic mass of an element, okay, to the 1/12th mass of carbon 12 isotope. Okay, and this atomic mass is expressed using which unit? AMU, that is atomic mass unit. Now it is changed as U, that is unified mass. Okay, so that time it was AMU. Now recently it is changed as unified mass. Okay, so 1 AMU equal to what? It is equal to 1.6606 into 10 raised to minus 24 gram, or 1.6606 into 10 raised to minus 27 kilogram. Okay, so atomic mass means what? It is the ratio of mass of an atom, of an element, to the 1/12th mass of carbon 12 isotope. Okay, and it is equal to this much in gram and this much in which one? 1.1. It is expressed in AMU. 1 AMU equal to this much, 1.6606 into 10 raised to minus 24 gram, and 1.6606 into 10 raised to minus 27 kilogram. Okay. In case of isotopes, isotope, just now I told you what is an isotope. In case of isotope, it is not to express, it is not to express the atomic mass easily, because it is having isotopes means here if you are taking the carbon, 3 isotopes are there. So in this case of isotopes, in place of atomic mass, we have to use which one? Average atomic mass. We have to use the term average atomic mass. And this average atomic mass is related to the relative abundance. Abundance means how much percentage that isotope is present, and also the isotopic masses. Okay, so average, in case of isotopes, in place of atomic mass we have to use which term? Average atomic mass, right? This average atomic mass is related to the relative abundance, or how much percentage of that isotope present, and the isotopic masses. And one equation is there to calculate the average atomic mass based on the, if they are given the relative abundance and isotopic masses, we can calculate the average atomic mass of isotopes. That is given by average atomic mass equal to M1x1 plus M2x2, depending on how many isotopes. 3 isotopes means what? M3, x3, etc. Mn, xn, depending upon the number of isotopes, divided by 100. Here Mn is the mass of the first isotope and its abundance, how much percentage is there. M2 is the mass of the second isotope and its abundance, like that. Okay, for example, Chlorine, one problem is given in the textbook. Chlorine is having two isotopes having the masses. Chlorine actually we know atomic number is 17, its mass number is 35. Okay, and one more is there for chlorine, one more isotope is there, that is chlorine 17 and 37. So what are the isotopic masses here? 35 and 37. Okay, so chlorine is having two isotopes with the masses 35 and 37 with abundance 75% and 25%. Okay, that means chlorine 35 17, this isotope is having 75% abundance, and chlorine 17 37 is having 25% abundance. Okay, so we have to calculate the average atomic mass. How we can calculate the average atomic mass? We can substitute in this equation. M1, mass of the first isotope, that is 35, into what is the abundance? How much percentage is there? 75, plus, okay, mass of the second isotope, how much it is? 37, into its abundance, how much it is? 25 divided by 100, what is it? 35.5 is the which one? Average atomic mass of chlorine. Okay, so in case of isotopes, we have to use which one? Average. We have to calculate the average atomic mass. So atomic means what? Mass means what? It is the ratio of atomic mass of an element to the 1 by 12th mass of carbon 12 isotope. Okay, and it was expressed using AMU, and AMU means 1 AMU equal to this much gram and this much kilogram. Okay, next term we are going to gram atomic mass. From the name itself it is there. Gram atomic mass means what? Expressing the atomic mass in gram unit. Simply we can say atomic mass in gram. Okay, but definition is there. Definition means it is the mass in grams of 1 mole of atoms in a monoatomic element. It is what? Mass in grams of which one? 1 mole of atom. Mass in grams of 1 mole of an atom in a monoatomic element, in an element or in an element. What is that? It is the mass in grams of 1 mole of an atom. Simply we can say it is expressing the atomic mass in gram. By definition we can say mass in grams of 1 mole of an atom. How much mass is there for 1 mole of an atom in gram? That is known as gram atomic mass. Okay, for example, all of you know atomic mass of magnesium is how much it is? It is 24 AMU. Okay, generally we can say it is 24 AMU. If you are writing that in gram, that is 24 gram means that will be what? Gram atomic mass. Very easy. Okay, 24 is atomic mass of 24 AMU is the atomic mass of magnesium. That if you are writing in gram, 24 gram, it is which one? Gram atomic mass. Next term is molecular mass. What is molecular mass? Molecular mass means it is the sum of mass of all the atoms present in a molecule. What is it? It is a sum of atoms of all the sum of masses of all the atoms present in a molecule. We know CH4, it is a molecule, right? What is the name of this compound? Methane. What is a water? H2O. H2O is a molecule. Okay. So how we can calculate the molecular mass of a molecule? Okay. It is very important for problems and all. It is there. So for example, methane I will calculate first. Okay. So methane, we know what is molecular mass. It is a sum of masses of all the atoms present in a molecule. Here carbon is the atom, plus mass of carbon plus mass of hydrogen. Okay, so how we will get the molecular mass means we have to multiply the atomic mass with the number, then adding up all the masses of atoms. Okay, so for example in CH4 how we will calculate? 1 carbon means how much it is atomic mass? 12. Okay, so 12 into how much number it is there? 1. Okay, plus hydrogen. 1 hydrogen is having atomic mass 1. How many hydrogen is there? 4. So 1 into 4 over no equal to how much it is? 12 plus 4, 16. So what is the molecular mass of methane? It is 16. So it is a sum of masses of all the atoms present in a molecule. How we can calculate? Just we have to add the masses of atomic masses. Okay, atomic masses, if more than one is there means multiply the atomic masses with the number, then adding up we will get the molecular mass. Next is water. H2O. How we can calculate molecular mass of H2O equal to? Here hydrogen is there, oxygen is there, right? So one hydrogen, for hydrogen it is 1, right? So how many hydrogen atoms are there? 2. So 1 into 2 plus oxygen. One oxygen, what is the atomic mass of oxygen? It is 16. What is it? 16. So how many oxygen atoms are there? 1. So 16 into 1 equal to how much is the molecular mass of water? 18. Okay. Then one more, glucose. Glucose means C6H12O6. What is the formula of glucose? C6H12O6. They can ask this question. Okay. So what is the how we can calculate the molecular mass of glucose? So what is the formula of glucose? C6H12O6. So how we can calculate? First we have to take carbon. So how many carbon atoms are there? 6. One carbon is having 12. What is the atomic mass of one carbon? It is 12. So how we will write? That's equal to 6 into 12 carbon plus hydrogen. We know 1. So how many hydrogen atoms are there? 12 into 1 plus how many oxygen atoms are there? 6 oxygen atoms are there. So one oxygen, all of you know what is 6? 16. Right? Okay. So 6 into 16. Clear? So first 6 carbon atom, 6 into 12 plus 12 hydrogen atom. 1 hydrogen 1, so 12 into 1 plus oxygen 6. 1 oxygen it is 16. So 16 into 16. So how much we will get? 12 into 70, 12 into 6, 72, right? Plus 12 plus 6 into 16 means what? 6 into 16, 6 into 6, 36, 96, right? Okay, so 96, 96. So total how much we will get? 72 plus 12 plus 72. So how much we will get? 2 plus 2, 4. 4 plus 6, 10. 7 plus 1, 8. 8 plus 1, 9. 9 plus 9, 8. 180. So what is the molecular mass here? 180. What is the molecular mass of glucose? 180. Clear? So how many atoms are there? If multiply that atom with number, then just take the sum. Okay, we will get the molecular mass. Here is 6 into 12 plus 12 into 1 plus 6 into 16. 6 into 16 means 6 into 6. 6 plus or 1 into 6. 6 plus 96 plus 12 plus 72, we will get 180. So what is the molecular mass of glucose? It is 180. Okay. So next term is gram molecular mass. Just like gram atomic mass, gram molecular mass means what is it? It is expressing the molecular mass in gram. Molecular mass in gram. Okay. So that is which one? Gram molecular mass. For example, here we calculated methane. It is 16 AMU. Okay. But in gram molecular mass, how we will write 16 AMU equal to 16 gram. Okay. So it is the mass of 1 mole of molecules. It is the mass of 1 mole of molecules in gram. Simply we can say it is the molecular mass in gram. Okay. Next is, so atomic mass over, then gram atomic mass, molecular mass, then gram molecular mass. Okay. Next is formula mass. What is formula mass means? Formula mass. Formula mass means in case of which one? In case of ionic compounds. In case of ionic compounds like NaCl, etc., the formula of the compound is not giving the exact, it is not representing the molecule, it is not representing the molecule, but it represents the ratio of number of ions present in that. Okay. So for example, in case of ionic compounds like NaCl and all, formula of the compound, it is not representing the molecule, but it represents the ratio of number of ions present in the that compound. Okay, so in that case we can't use which one, instead of molecular mass we can use which term, formula mass. In case of which type of compounds, ionic compound. Okay, so formula mass is equal to the sum of mass of ions, sum of the atomic mass of ions. Okay, we will get which one, formula mass. For example, NaCl. NaCl means it is having Na plus Cl minus ions. Okay, so Na plus, how we can calculate the formula mass of NaCl means Na plus is having the atomic mass 23 and Cl minus is having the atomic mass 35.5. So what is the formula mass of NaCl? NaCl equal to, how much it is? 8. 2 plus 3, 5. Okay, so 58.5 is the formula mass of which one? NaCl. So just like molecular mass it is, but in case of ionic compound we are using the term formula mass in place of which one? Molecular mass. So that is which one? The formula mass. Okay, after that one more term it is coming, mole. What is a mole? The term mole is introduced by the scientist Ostwald. Meaning of mole is heap. Heap means what? All of you know what is a heap or pile. Heap or pile. Okay. So what is a mole means? It is the amount of substance that is equal to the substance that as many as particles like atoms or ions or molecules present in, okay, it is the amount of substance that is equal to the particles present in 12 gram of carbon 12 isotope. So what is a mole? It is an amount of substance, okay, as particles like ions or atoms or molecules that exactly equal to the 12 gram of carbon 12 isotope. That means in carbon 12 gram of carbon 12 isotope, how much amount of atoms or ions or molecules are present? Okay, so that will be equal to which one? The mole or 1 mole. So mole means what? Mole means it is the amount of substance exactly equal to the particles like ions or atoms or molecules present in 12 gram of carbon 12 isotope. Okay, and this mole is equal to 6.023 into 10 raised to 23 particles. Okay, so 1 mole is equal to almost 6.023 into 10 raised to 23 particles. This number is known as Avogadro's constant. What is Avogadro's constant? It is equal to 6.023 into 10 raised to 23 particles, and Avogadro constant is represented using the letter Na. Okay, so Avogadro, what is the value of Avogadro's constant? It is 6.023 into 10 raised to 23 particles. So 1 mole equal to 6.023 into 10 raised to 23 particles. Okay, and it is known as Avogadro's constant and it is represented by the letter Na. So generally we can say 1 mole equal to 6.023 into 10 raised to 23 particles, and 1 mole equal to, in case of gas molecules we can say 1 mole equal to 22.4 liter gas, 22.4 liter gas at STP. STP means what? I will tell next. Okay, STP is coming, standard temperature and pressure, that is STP. Okay, so 1 mole equal to how much particles? 6.023 into 10 raised to 23 particles, and or 1 mole we can represent 1 mole equal to 22.4 liter gas at STP. Okay, or we can say 1 mole equal to 1 gram atomic mass. Okay, or 1 mole molecular mass of 1 mole gram molecular mass, okay, of which substance, molecular substance, or 1 gram formula mass of an ionic compound, 1 gram atomic mass of an element, or 1 gram molecular mass of a molecular substance, or 1 gram formula mass of an ionic compound. Okay, so 1 mole means it is equal to 6.023 into 10 raised to 23 particles. Okay, or it can be represented as 22.4 liter of gas at STP, or 1 gram atomic mass of an element, or 1 gram molecular mass of a molecular substance, or 1 gram, which one, 1 gram formula mass of an ionic compound. Okay, the next is STP. Just now I told you STP. What is STP means? It is standard temperature and pressure. We know in most of the time we are taking the temperature expressing based on which is the standard unit of temperature. It is in Kelvin. Okay, so that is what is STP condition means. What is the standard temperature and pressure using in experiments in chemistry. Okay, so STP, standard temperature pressure. What is the standard temperature? Is 273 Kelvin. What is the standard temperature? 273 Kelvin. Then standard pressure, STP means standard temperature and pressure. Standard pressure is 1 bar or 1 atmosphere pressure. Bar and atmosphere is the unit of pressure. Okay, so standard temperature means 273 Kelvin and standard pressure means 1 bar or 1 atmospheric pressure. Then standard volume means what? 22.4 decimeter cube. Okay, or 22.7 dm cube in, okay, 22.4 dm cube or 22.7 dm cube. Okay, so that is the standard temperature, pressure and volume condition. 22.4 dm cube at 1 atmospheric pressure. Okay, at atmosphere. Okay, here it is 22.7 means what? At bar. If the pressure is at in bar, then 22.7 dm cube is the standard volume, and if the pressure is in atmosphere, what is the standard volume? It is 22.4 dm cube. So that is the terms, atomic mass, molecular mass, gram atomic mass, then gram molecular mass, formula mass and mole concept. Clear all of you? Next is some formulas used in calculations. Okay, for example, calculating number of moles, number of atoms, etc. So no need of by hearting this one. Okay, I will just tell what are the formulas. First is calculation of number of moles. Okay, that means number of moles of atoms, number of moles of molecules, how we can calculate. So first equation is number of moles of atoms equal to mass of substance in gram divided by gram atomic mass. In a problem if you want to calculate the number of moles of atoms, means mass of the substance, they will give this much gram weight, they will give the substance, divided by the gram atomic mass. Okay, so that is the number of moles of atoms. For number of moles of molecules equal to mass of substance in gram divided by, in place of gram atomic mass, what we have to use? Gram molecular mass. Okay, so number of moles of atoms equal to mass of the substance in gram divided by gram atomic mass. Number of moles of molecules equal to mass of the substance in gram divided by gram molecular mass. Okay, next is how we can calculate number of atoms. It was number of moles of atoms, here it is number of atoms. Number of atoms equal to number of moles of atoms into Na. Na means we know Avogadro's number. Okay, number of atoms equal to number of moles of atoms into Avogadro's number. Then number of molecules equal to, how we can write, number of moles of molecules we calculated here into Avogadro's number. Okay, next is mass of a molecule or compound. How we can calculate the mass of a molecule or a compound equal to gram molecular mass divided by Avogadro's number. Gram molecular mass divided by Na means Avogadro's number. So these are the main formulas we are using. No need of by hearting. Next one term is percentage composition. Percentage composition means what is it? It is a percentage mass of the component in 100 gram of the compound. Suppose 2 gram of sugar is present in one compound. Okay, so mass percentage or percentage composition equal to mass of the sugar, mass of that component in 100 gram of the compound. Inside that compound, how much amount is there, that given given what is that component, that is known as which one? Percentage composition. So that is equal to mass of component divided by gram molecular mass of the compound into 100. Okay, that means in 100 gram, how much gram is that particular component is present, that is percentage component. So clear these formulas and percentage components. Next is very important, empirical formula and molecular formula. Empirical formula and molecular formula. So what is empirical formula? Means it is the simplest formula that gives the idea about the ratio of number of atoms present in a compound. Just it will give the number of atoms in a compound. For example, OH. OH means oxygen and hydrogen is present. Okay, ratio just we will get, but we don't know the actual number of molecules present in an atom using empirical formula. So empirical formula means it is a simplest formula, just gives about the ratio of number of atoms of elements present in a compound. That is empirical formula. In short, we can write it as EF. Okay. Then next is molecular formula. What is molecular formula? Means it is a true formula of a molecule that gives the actual number of atoms of elements present in that molecule or a compound. Okay. For example, H2O. It is the molecular formula of water. That means we know water containing 2 hydrogen and 1 oxygen. So it is a true formula. It gives total number or actual number of atoms of elements present in a molecule. The empirical formula means it just gives the ratio of number of atoms present in a compound or a molecule. Okay, definition is not very much important. Problems based on this is very important. They will ask deduct the formula of they will give the percentage and all. We have to calculate percentage of each atoms present in that compound. We have to deduct or we have to find out the formula, empirical formula or molecular formula. Okay, so we will do the problems. First, before moving to the problem, we have to know some formulas to calculate the empirical formula and molecular formula. First one is molecular formula equal to empirical formula into N. Okay, so short you can write molecular formula as MF and empirical formula as EF. Okay, so molecular formula equal to empirical formula into small n. So what is N? N equal to molecular mass, okay, divided by empirical formula mass. Okay, so we will do one problem based on this, so you will understand what is it. Okay, so here given a compound with a molecular mass of 34 gram per mole, molecular mass is given, is known to contain 5.88% hydrogen. What is the percentage of hydrogen? 5.88, and 94.12% oxygen. Find the molecular formula of compound. So percentage of the atoms or elements present is given and the molecular mass also given. We have to calculate the molecular formula of the compound. Okay, so you have to know this column. First you have to 1, 2, 3, 4, 5, 6 columns are there. The heading you have to by heart. Okay, so first column it is elements. Elements means which are the elements present in this question. Okay, we know hydrogen is present, right? Then oxygen is present. Then next column is percentage composition. How much percentage it is present? Very easy problem. Okay, percentage composition means here it is given hydrogen is 5.885%. Okay, and oxygen is 94.12%. Next column is atomic mass. All of you know what is atomic mass for hydrogen? It is 1 and for oxygen it is 16. Okay. Next column is percentage composition divided by atomic mass. You can see here percentage composition divided by atomic mass. Okay. So we know percentage composition for hydrogen it is given 5.88 divided by atomic mass. So what is it? 5.88. Next here 94.12 divided by 16, it is 5.882. Here it is 5.88 and here it is 5.882. Next column, divide values by smallest among them. What is the meaning of that? Is divide values by smallest among them means here we have to take each one. 5.88 is there, 5.882 is there. Divide each one with the smallest. We know in 5.88 and 5.882, 5.88 is the smallest. So divide these 5.88 by 5.588, then 5.882 divided by 5.88. Okay, take these values and divide by which one is the smallest among them. Okay, so 5.88 divided by 5.88 we will get 1. Here 5.882 divided by 5.88 we will get 0.999. Okay, then last column is rounding off, rounding the numbers to rounding to nearest whole number. So we will get 1 here, so no need of rounding it. Okay, 1 we can write, but the next one is 0.999, so we can round it as 1. Okay, so the first column is elements, second column is percentage composition, third is atomic mass, and the fourth is percentage composition divided by atomic mass. Then divide the values by smallest among them, then rounding to nearest whole number. Okay, so after this we know here it is 1 and 1 we got. Okay, so empirical formula, what is the value we got in the last column? Okay, 1 and 1 for hydrogen and 1 for oxygen. So what is the empirical formula of that compound? How we can write is, we can write is as HO, that is H1O1 or OH. You can write anyone. I am writing H1O1. Okay, so H1O1, this is the which one? Empirical formula of the given compound. So last column, which number is coming, that we can write is as the empirical formula. Hydrogen 1 and oxygen 1. But the question is, we have to calculate which one? Molecular formula. Okay, so molecular formula equal to empirical formula into N, right? Okay, so molecular formula equal to empirical formula into N. So I am writing molecular formula equal to, here empirical formula means what? HO into N, right? But we don't know N. So we know how we can calculate the N. N equal to molecular mass divided by empirical formula mass. Here it is given, molecular mass is given in the problem, how much it is? 34 gram. Okay, so 34 divided by empirical formula mass. How we can calculate the empirical formula mass? Just like molecular formula mass, we can calculate the empirical formula mass. Okay, we know here empirical formula is HO. So how we will calculate the empirical formula mass? Empirical formula mass equal to hydrogen, 1 hydrogen, right? 1 plus 1 plus 1 oxygen. 1 oxygen is how much it is? 16. So 1 into 16 equal to, we will get 17. So what is the empirical formula? Just like molecular formula, multiply the numbers with the atomic mass, then add all together, take the sum. Okay, so we will go to the empirical formula 17. So 34 divided by 17 equal to 2. So what is the value of N there? 2. So I will substitute the value of N here. Okay, that's equal to HO2. HO twice N. Okay, so what is it? H2O2. Can I write H2O2? So what is the molecular formula of the compound? H2O2. Okay, so clear all of you calculating the molecular formula of a compound. Next problem is, a compound contains 4.07% hydrogen, 24.47% carbon and 71.65% chlorine. So compound containing hydrogen, carbon and chlorine. Its molar mass is 98.96. What is the empirical formula and molecular formula? So you have to calculate empirical formula and molecular formula. So we know the column element. So carbon, hydrogen, chlorine. Percentage composition is given 24.27, 4.07, 71.65. It is given here. Then atomic mass. We know carbon 12, hydrogen 1 and chlorine 35.5. Then percentage composition divided by atomic mass. Okay. So first is 24.27 divided by 12. We will get 2.02. Next is 4.07 divided by 1. We will get 4.07. Then 71.65 divided by 35.5. We will get 2. Okay. Next column, divide the values by the smallest among them. Okay. So here it is given 2.02 is there, 4.07 is there, 2.01 is there. Which one is the smallest? 2.01. Okay. So take each value and divide by 2.01. So here 2.02 divided by 2.01 approximately we will get 1. Next is 4.07 divided by 2.01, 2.02. Next is 2.01 divided by 2.01. So these values we have to take, and in this which one is the smallest one? So divide these values with the smallest one. So we will get 1 here. Okay. So rounding of the values to the next whole number. So 1, no need of rounding, 1 only. Then 2, we know how we can rounding the rules and all. So it is less than 5, so it is 2. Okay, rounding to just whole number, so it is 2. Then 1. Okay, so how we can write the empirical formula? Empirical formula equal to carbon 1, hydrogen 2, then chlorine 1. Okay, so empirical formula we got. Next from that we have to calculate the molecular formula. Okay, so for knowing the molecular formula we have to know which one? N. Okay, molecular formula equal to here empirical formula CH2Cl2. So I am clearing here. Okay, so we know molecular formula equal to, what is molecular formula? Molecular formula equal to empirical formula. I am writing AF into N. Right. Empirical formula already we know, but N we don't know. So N equal to molar mass divided by empirical formula mass. Empirical formula mass. Right. Empirical formula mass. Molar mass we know it is given in the problem how much? 98.96 divided by empirical formula mass. How we can calculate for this one? CH2Cl is the empirical formula. We have to calculate its mass. How we will calculate? See, empirical formula mass. Empirical formula mass equal to, how I will calculate? Just adding up the all the atoms mass. Okay, so carbon 1 into 12 plus hydrogen 1 into 2. How many is there? 2 into 1 is the atomic mass. Then chlorine. Chlorine means it is 35.5. So how many chlorine atoms are there? 1. So 1 into 35.5. Okay. We will get it is 49.50. What is the answer? We are getting 49.50. 49.50. So can I substitute this 49.50 here? Empirical formula mass 49.50. Okay. So that is equal to how much? 2. So we will get the N equal to 2. Okay. So N we got 2. Then how we can write the calculate the molecular formula? So molecular formula equal to empirical formula into N. Right. Okay. So we already calculated the empirical formula. How much we got? C1, H2 and Cl1 was the empirical formula. We already wrote into how much is the value? N2. Okay. So what is the answer? C2, H2 into 2, 4. H4, Cl1 into 2, Cl2. So what is the molecular formula of the compound? C2H4Cl2. What is the empirical formula of the compound? CH2Cl. C1H2Cl1. Okay. So clear all of you. This is the today's topic. Thank you girls.